Hello everyone, welcome to the Resultant. Is audio video clear? Is your audio video clear? Is your audio video clear? Absolutely. Quickly join the session. Quickly join the session. So we'll be discussing practice session for Geotechnical Engineering. Quickly join the session. Everyone join the session. So let us start then. So this is all about me. This is all about me. You can go through. Okay, we'll start. So this is all about me. You can go through. Okay, so question number first on the screen. Mark down the answer. So question number first on your screen. Everyone mark down the answer. Okay, mark down the answer. So the question says here, a good earth brick can be rolled without breaking in small threads of diameter. So a good earth brick can be rolled without breaking into a small thread of diameter. So what is the answer for this question? Anyone? What is the answer for this question? Okay, so if we look at the plasticity, if we look at the plasticity, okay, so a good brick can be rolled, or okay, a good soil can be rolled into threads, absolutely correct, into threads up to diameter 3 mm. Okay, so we can say a soil is a good plastic, okay, good plastic material. So you can go with the 3 mm diameter. So a good earth brick can be rolled without breaking into small threads of diameter 3. Okay, absolutely correct. So this is an easy question. Another question to be discussed. Another question. What is the answer for this question? Which of the following is the most accurate? Which of the following is the most accurate for the determination of water content of the soil? So, which is the most accurate? We have discussed this in the class. There are various methods. The first method is your okay. The first method is oven dry method. Arnab is asking is the correct answer. Okay. Okay. So, which of the following is the most accurate method for the determination of water? Absolutely correct, sir. Oven dry method is the most suitable method. So what is the procedure? What is the procedure for this test? Okay. What is the procedure? Sir, first we are taking the soil sample in the container. Soil sample in the container. It has the mass M1. Let us suppose. Okay. Then we put the soil sample in the oven dry. Okay. In oven dry for oven drying for 24 hours. Okay. For 24 hours. Then after the 24 hours, okay, we again weigh the sample. Let the mass is again M2. Okay. Sir, water content is then defined as okay M1 minus M2 M1 minus M2 upon M2. Absolutely correct. Upon M2. So it is percentage. It is represented in percentage. So we'll multiply this by 100. Absolutely correct. Okay. Absolutely correct. Also, I will say, sir, if we have the organic soil, for the organic soil, we are putting the oven dye temperature as 65 degrees Celsius. Okay. Absolutely correct. Sir, if we have the inorganic soil, okay, inorganic soil inorganic soil we are putting the temperature 105 to 110 degrees Celsius. Absolutely correct. Absolutely correct. Okay, sir, if we have the soil which contains gypsum, okay, which contains gypsum. There we are putting the temperature as 80 degrees Celsius. Okay, we are putting the temperature as 80 degrees Celsius. Absolutely correct, no. Next question on your screen. Next question on your screen. Quickly mark the answer. The plastic limit and the liquid limit of soil sample is given. The plastic limit and liquid limit of the soil sample is given. Okay. The percentage of the soil fraction with the grain size finer than 0.002 mm is 25. The activity ratio is. The activity ratio is. How can we define activity ratio? The activity ratio is. Quickly mark down the answer. C is the answer. Okay. How can we write down the activity ratio? Sir, we define the activity ratio like that. We define the activity ratio. Activity ratio is simply the IP, okay, plasticity index of the soil upon the percentage of clay fraction. Remember, percentage of the clay fraction. Percentage clay fraction. Absolutely correct. That means clay fraction will be, okay, will be passing 0.002 mmcu. Absolutely correct, sir. Okay. Your IP value can be 70 minus 35. 70 minus 35 divided by percentage of clay. Sir, that percentage of clay is 25. Okay. So you will get 35. Okay. 35 upon 25. And the answer will be 1.4. Answer will be 1.4. Remember here an important point. Remember here an important point. If the question was like that, if the question was like that, sir, the percentage, okay, the coarser fraction, the coarser fraction then, okay, then 0.002 mm, okay, is 75 or is 60%. Okay, okay. So will you divide by 60? Will you divide by 60? Will you divide by 60? No, sir, we will not divide by the 60. Will not divide by the 60. Since this is coarser fraction, since this is coarser fraction, sir, if we have to get the finer fraction, for finer fraction, we'll do 100 minus 60. 100 minus 60. Absolutely correct. Your finer fraction will be now 40. Okay. So this was the mistake here. This was the mistake here. Okay. Absolutely correct. Next question on your screen. Next question on your screen. Harshita is absolutely correct. Harshita is saying answer is 3. Okay, answer is C. Anyone? Anyone again? So a fully saturated soil is said to be. We have the fully saturated soil. You have the fully saturated soil. Absolutely correct, sir. For the fully saturated soil, okay, that soil we called as. Okay, C is the answer. Look here. We have the saturated soil. We have the soil. Sir, the soil actually contains air, water, and soil solids. Okay. So look at the concept. Sir, the soil actually contains air, water, and the soil solids. Okay. Absolutely correct, sir. Sir, if the soil is completely saturated, if the soil is completely saturated, sir, then the soil will be air, water, and solids. Okay, solids. If the soil is completely saturated, that means only water and soil solids are present. Only water and soil solids are present. Okay, so water and soil solids are present. So it will be now two-phase system. It will be now two-phase system. Absolutely correct, sir. This will be two-phase system. So you can go with two-phase system with soil and water, sir. It will be soil and water only. If the soil is dry, in that case, water is zero. Water content, okay, water is zero. Now the water is zero. That means the soil is air and two-phase system, air and soil solids. Okay, air and soil solids. Absolutely correct. Okay, so the answer is C. Next question. Quickly mark down the next question. Quickly mark down the next question. It's a very important session. It's a very important session. It's a very important session for you. So select the correct range of the density index. So we define the density index. I'll write down the definition also. The density index. Quickly. So Harshita is saying B is the answer. B is the answer. Okay. Arnav is saying A is the answer. Anyone else? Anyone else in the class? So select the correct range of the density index. Remember the density index is, sir, if we define the density index ID, that is written as simply, Okay, E max, that is void ratio in the loosest state, maximum void ratio minus E void ratio in the natural state upon what? Upon E max. Okay, upon E max minus E minimum. E minimum. That is void ratio in the dense state. Okay, sir, multiply by 100 because we write down this in percentage. Okay, we write down this in percentage. Sir, if we have the soil at the dense state, if we have the soil at dense state, soil is at dense state, that means your E is, your natural void ratio will be E minimum. Okay, in that case id will be, in that case your id will be, sir, your id will be 1 simply. Okay, it will be 1 simply. Okay, sir, if the soil is in loosest state, that means your E void ratio, natural void ratio will be equal to E maximum. Okay, sir, in that case, if we put the E value as E maximum, in that case, your ID value will turn out to be, okay, it will turn out to be 0. So the density index ranges from 0 greater than, okay, 0 to 1. Okay, it will range from 0 to 1 id, it will range from 0 to 1. Okay, so your correct answer will be A. Okay, correct answer will be A. Absolutely correct, sir, correct answer will be A. Okay, next question on your screen. Okay, so next question on your screen. So when the liquid limit of the soil is less than the plastic limit, then the plastic index is reported as. So B is the answer. Arnab is saying B is the answer. Anyone else? So when the liquid limit of the soil is less than plastic limit, okay, then the plastic index is reported as. How can we write down the plastic index? If we define the plastic index, if we define the plastic index, IP, absolutely correct, sir. So your IP is simply given as, your IP is simply given as liquid limit minus plastic limit. Okay. Now, when the liquid limit is less than, that means, sir, liquid limit is less than plastic limit. Absolutely correct. So, in that case, IP will be negative. IP will be negative. But, sir, we are not getting this negative. We are not noting down this negative. Okay, we are not reporting this negative. So, in that case, we'll simply write down IP is the 0. We'll write down IP is 0. Okay. So, IP doesn't have the negative value. So, you may go with the answer B. Okay, absolutely correct. You may go with the answer B. Okay, next question on your screen. So the B is the answer. The property of the soil, the property of the soil due to which the loss in the shear strength caused by the remolding can be regained with the time is known as. Remember here, Supel, it is thixotropy. Okay, it is thixotropy. Okay, so you may get confused here. It is thixotropy. So if we are getting the soil sample, if we are getting the soil sample, okay, so let us suppose it has some shear strength, it has some shear strength. Okay, absolutely correct. Okay, sir, after the remolding, okay, after remolding the soil sample, it will lose the shear strength, it will lose the shear strength. Okay, but if we place this, okay, if we place the soil sample, okay, if we place the soil sample like that, it will regain the strength, it will regain its strength. Okay, and that regain in the strength is simply called as thixotropy. Okay, that is called thixotropy. B is the correct answer. Okay, B is the correct answer. Absolutely correct. B is the correct answer. Next question. Next question. These are very easy. These are very easy questions. These are very easy questions. Arnab, Harshita, everyone. I want everyone's answer. Harshita is saying B is the A is the answer. Okay. Arnab is saying A is the answer. Anyone else? So we have the Atterberg's test, which was carried on the soil. So the liquid limit reported as 45, plastic limit reported as 30, shrinkage limit reported as 15. So what is the value of plasticity index? Simply your IP is liquid limit minus plastic limit. So the liquid limit is 45 minus the plastic limit is 30 and the IP value will be 15%. Okay. So what is shrinkage index? What is shrinkage index? your shrinkage index will be simply plastic limit, that is 30, minus shrinkage limit, that is 15, and the shrinkage index is also 15. So we will go with the answer A. Okay, plastic index is A. Absolutely correct. Okay, next question on your screen. IP minus IS. Absolutely correct. So next question on your screen. Next question on your screen. Okay. Okay is the answer. Look. So this is the level of preparation you need for AEG exams. Remember, for all state AEG exams, you need this type of preparation. Okay. Arnab, Harshita. So we are saying here Lextrine soils. So Lextrine soils are the deposited on the lag pads. Okay, this is easy to understand. These are deposited on the lag pads. Sir, if we have this soil which is transported through the water, what that soil is called? That is transported through the water. That soil will be simply called as the, okay, that simply soil will be aloe vera soil. Aloe vera soil. Sir, if the soil is deposited by the wind, okay, by the air or the wind, that soil is called olean soil. Olean soil, absolutely correct. Okay, so these are the important points. Okay, these are the important points. Next question. Next question. The ratio of the volume of the air void to the volume of the total void is known as volume of the air void. It is volume of the air void, not the volume of total voids. Okay, so volume of the air void is to the total volume of the voids. Okay, Harshita is saying D is the answer. Arnav is saying D is the answer. Anyone else? Anyone else? I want everyone's answer. I want everyone's answer. Quickly mark down the answer. So the ratio of volume of air void to the volume of total void is known as. So what is that? What is that property known as? So if we look at the percentage air voids, B होगा बिल्कुल. देखो अगर हम देखते हैं, देखो अगर हम देखते हैं यहाँ पे एक सेकंड देना. अगर हम देखते हैं एयर कंटेंट AC से डिनोट करते हैं सर, दैट इज द वॉल्यूम ऑफ एयर अपॉन वॉल्यूम ऑफ द वाइडस मल्टीप्लाई बाय 100. एब्सोल्युटली करेक्ट सर. Sir, the correct answer will be air content. Okay, the correct answer will be air content. And also, if we look at the percentage air void, that is denoted by Na. Okay, Na. I will write down this Na. So this Na percentage air content is volume of air upon total volume of the soil. Total volume of the soil. Okay, total volume of the soil. Absolutely correct. Okay, sir. If we have the degree of saturation plus the percentage air plus air content, sorry. Sir, that is equal to 1. That is equal to 1. Absolutely correct. That is equal to 1. So these were the important relations. That is equal to 1. So what is the answer? Air content is the answer. Next question on your screen. Next question. So these are basic questions. These are the basic questions. Okay, these are basic questions. These are the basic questions. So C is the answer. Arnav is saying C is the answer. Anyone else? Harshita is saying C is the answer. So the valid range of degree of saturation of the soil. Degree of saturation of the soil. So how is the degree of saturation defined? So it is denoted by S. Okay, it is denoted by S, and it is defined as, okay, volume of the water to the volume of the voids. Okay, how much percentage of the voids are filled with the air? Okay, filled with the air. Absolutely correct. So your degree of saturation, remember, if the soil is dry, sir, for dry soil, volume of water is zero. Volume of water is zero. That means your S value, that means your S value is zero. Absolutely correct. Sir, if the soil is saturated, if the soil is saturated, in that case, volume of the water will be equal to volume of the voids. That is, all the voids will are filled with the water. Okay, in that case, saturation will be 100%. In that case, saturation will be 100%. So the saturation value lies between 0 to 100. Okay, it can be 0, it can be 100. It can be anything between 0 to 100. So we can go with the C answer. Absolutely correct. Next question. Next question. Next question on the screen. So we have the bulk density given. We have the water content given. Now the dry density of the soil is. So dry density of the soil is. How is the class? Arnab. Harshita, how is the class? So I want your feedback. How is the class? So we have a soil sample. Okay. B is the answer. B is the answer. Anyone else? Anyone else? Anyone else? A soil has the bulk density of 22. Okay. Has the bulk density of 22 and the water content is 100%. The dry density of the soil is. Okay. Okay. Thank you. So we have the gamma d value. We have to find out the gamma d value. Your gamma d value is gamma bulk upon 1 plus W. Okay, 1 plus W. So the gamma bulk value is 22. Okay, gamma bulk value is 22 upon 1 plus water content. Sir, the water content is 10%. That can be written as zero point 0.1. Okay, that can be written as zero point 0.1. So the gamma d value turn out to be 22 upon 1.1. 1.1, and the value will be simply 20. Okay, 20 kilonewton per meter cube, because the gamma bulk has the units of kilonewton per meter cube. Okay, absolutely correct. Your correct answer will be B. Your correct answer will be B. Okay, next question on the screen. अर्नब अपने फ्रेंड्स को भी लाओ. Please bring your friends too. हर्षिता, हर्षिता अपने फ्रेंड्स को भी क्लास में लाओ. So bring your friends too in the class. This is English class. Okay, so all the content will be provided in the English language. So where the picnometer which is used for? Picnometer is used for. D is the answer. D is the answer. Harshita is saying D is the answer. Okay. Arnab is saying D is the answer. So we have the picnometer is used to determine what? This picnometer is used to determine water content and the specific gravity. Okay. Specific gravity. For the water content, for the calculation of water content, okay, by the picnometer method, by the picnometer method, so you must know the specific gravity of the soil. You must know G of the soil. And remember, this is used for the coarse soils. It is used for coarse grained soils. Coarse grained soil is absolutely correct. Okay, it's used for coarse grained soils. So this picnometer is used for water content and the specific gravity. Okay, next question on your screen. Next question on your screen. So we have the minimum water content. Okay, in a soil at which the soil just begins to crumble when rolled into the threads of 3 mm dia is known as. So what is that known as? So what is the limit? What is the limit of the soil then? Quickly mark down the answer. It's a very important session. 40 questions will be done here. 40 questions will be done here. So we have the minimum water content in the soil at which the soil just begins to crumble when rolled into threads of 3 mm in dia is known as. Okay. So for the calculation of the plastic limit, sir, for the calculation of the plastic limit, sir, we are following the procedure like that. We are following the procedure like that. We are taking the glass sheet. Okay, we are taking the glass sheet. On the glass sheet, we are rolling the soil. We are okay. We are rolling the soil sample. We are rolling the soil sample by the hand, like that, by the hand. Okay, sir. If the soil breaks at 3 mm diameter thread, at 3 mm diameter thread, it starts crumbling. Then at that limit, at that water content, this water content will be plastic limit. Okay, this water content will be the plastic limit. So you can go with the plastic limit is the correct answer. Plastic limit is the correct answer. So for the calculation of the plastic limit, you are taking the soil sample on the glass sheet, then you are rolling it by the hand and making it the threads. Okay, making it the threads of dia 3 mm. So if the thread breaks at the 3 mm, starts scrambling at the 3 mm dia, that water content will be corresponds to plastic limit. Next question on your screen. Next question on your screen. Next question on your screen. So which of the soil is transported through the wind? Which of the soil is transported through the wind? Harshita is saying A is the answer. Harshita is saying D is the answer. Okay, Arnav is saying A is the answer. Most of the books are providing A is the answer. Okay, A is the answer. So if we look at this Leos, okay, this Leos is wind blown dust. It is wind blown dust. Absolutely correct. Okay, it is wind blown dust. Absolutely correct, sir. It has the high compressibility. It has the high compressibility. Sir, it has low density. It has low density. Low density. That is, these soils are loose. Okay, low density. These are loose soils. Sir, as these soils are loose, they have high permeability. They have high permeability. Okay, they have high permeability. So you can go with A. Okay, you can go with A. Next question on your screen. Next question on your screen. So A is the answer. A is the answer. Easy to understand. We have the saturation S plus the air content AC. Sir, that is equal to 1. That is equal to 1. Okay. Sir, the degree of saturation is 60%. That is, it is 0.6. 0.6 plus the air content, okay, is equal to 1. So the air content will be simply now, your air content will be simply now 1 minus 0.6, and that will be equal to zero point 0.4. Okay, that will be equal to zero point 0.4, and the will be noted as 40%. 0.4 is the 40% in the percentage. So you can go with A is the answer. Okay, can go with A is the answer. Next question on your screen. Next question on your screen. So the water content of the soil, which represents the boundary between plastic limit and liquid state. Plastic limit and liquid state. That is called as. Quickly mark down the answer. Only two answers are there. I want five answers. Everyone, I want five answers. I want five answers. So you have the soil sample first. Okay, you have the soil sample first. Absolutely correct, sir. These are soil sample. Let us suppose it is at infinite water content. It is at the infinite water content. Absolutely correct, sir. Sir, we are drying the soil. We are drying the soil. It is volume. It is volume. Here it is volume V. Okay, here it is volume V. And here it is water content W. Sir, we are drying the soil. It is water content and volume starts reducing. Okay, sir, it will reach up to plastic limit. It will reach up to, sorry, it will reach first liquid limit. It will reach up to liquid limit first. Wait a second. Sir, it will reach up to liquid limit first, then it enters into the plastic limit. Okay, after the plastic limit, it enters into the okay, it enters into the shrinkage limit. Absolutely correct, there is a shrinkage limit. Okay, after the shrinkage limit, there is no reduction in the volume. The volume will remain constant. The volume will remain constant. Okay, sir, the soil will be, this will be liquid limit, this will be plastic limit, this will be plastic limit, and this will be shrinkage limit. Sir, this will be liquid. This will be liquid state soil. This will be plastic state soil. Okay, plastic state. Sir, the boundary between plastic and liquid is liquid limit simply. Next question. Next question. A dry soil has a specific mass of 1.35. If the specific gravity of the soil salt is 2.7, then the void ratio is. Then the void ratio is. So quickly define the void ratio. Okay, the dry soil has a specific mass of 1.35 and the specific gravity of soil salt is 2.7. Okay, what is the void ratio? What is the void ratio? What is the void ratio? Since you know the mass specific gravity, that is GM, denoted by GM, that is written as the specific gravity of the solid is GS upon 1 plus E. Upon 1 plus E. Absolutely correct, sir. Upon 1 plus E. Okay, sir. we have to calculate the void ratio. Okay, so you can calculate GM is given as 1.35. Okay, that is equal to GS value is 2.7 upon 1 plus E. Okay, 1 plus E, and your 1 plus E value will be turned out to be 2.7 by 1.5, 2.7 by 1.35. Okay, and 1.35 value will be equal to 2. Okay, equal to 2, and your E value will turn out to be 2 minus 1, and that will be 1. Okay, your E value is 1. B is the answer. Okay, so Harshita is saying B is the answer. Absolutely correct. So this is a very, very important relation. Your mass specific gravity is gravity of the solid is specific gravity of the solid is by 1 plus E. Next question. Next question. Mark down the answer. We have a project engineer who collects the soil sample. Okay, who collects the soil sample which has the moist unit weight at 18.5 kilonewton per meter cube. Okay, find the void ratio. You have to calculate the void ratio and assume the unit weight of the water as 9.81 and the water content of the soil 22%. Okay, I will wait for this question. I will wait for this question. Arnav and Harshita, okay, they have provided every correct answer. They have provided every correct answer. So we have a project engineer who collects the soil sample of red soil, which has the moist unit weight of 18.5. Okay, 18.5. How can we calculate gamma bulk? Sir, how can we calculate gamma bulk? Remember, your gamma bulk value is simply equal to, okay, it is G plus ES, specific gravity G plus ES by 1 plus E. Okay, 1 plus E. What is given in this question? What is given in this question? Multiply by gamma W. Multiply by gamma W. Okay, multiply by gamma W. Or I will calculate like this. Or I will calculate like this. Find the void ratio. Okay. So your gamma D value. Your gamma D value is gamma bulk. Okay, gamma bulk upon 1 plus E. Okay. Then after gamma bulk value is given as your gamma bulk value is given as, okay, sorry, 1 plus W. Your gamma bulk value is given as G gamma W by 1 plus E. G gamma W by 1 plus E. Okay, 1 plus E. 1 plus E. Okay, G gamma W by 1 plus E. These are the equations which are used here. Anyone? Harshita, Arnab have solved this question. It's an easy question. A little bit tough on the calculation side. Okay. So the gamma bulk value is 18.5. Absolutely correct, sir. 18.5 by 1 plus water content is 0.22. So you will calculate here gamma D. Now gamma D value is G gamma W by 1 plus E. That is not also given here. How can you calculate this? Anyone? We have the another relation. Your ES is equal to GW. Okay. ES is equal to GW. Absolutely correct. ES is GW. So ES is GW. So you can calculate gamma bulk. You can calculate gamma bulk is from this relation. Gamma bulk is G plus ES. In place of ES, I will write down GW. I will write down GW. Okay. Divided by 1 plus E. 1 plus E. Absolutely correct. Multiply by what? Sir, multiply by gamma W. That is 9.81. Okay. So gamma bulk value is given as 18.5. So from this equation, you can calculate the G value. Okay. You can calculate the G value. Then after calculation of the G value, okay, after calculation of the G value, absolutely correct, sir. And after calculation of this gamma D value, that is 18.5 by 1 plus 0.02. Okay, you can put these values in this equation, that is G gamma W by 1 plus E, and you will calculate the E value. This is easy. Okay, this is easy. You can do this. Next question. Next question. So the question says here, the scientist collected saturated soil sample which has the volume of 200 centimeter cube. Okay, and have the unit weight of 220 grams. After that, if the dried weight of the soil is 180, then the water content is. How can you calculate the water content? Then the water content is. So how will you calculate this water content? Sir, we have noted down the formula from the water content, that it is simply the mass of the water upon mass of the solid is multiply by 100. Absolutely correct, sir. Mass of the water by mass of the solid is multiply by 100. Okay, absolutely correct. Sir, the mass of water will be, if the soil sample is moist, it has a weight of 220 grams, and then after drying, its weight is 180 grams. That means the weight of water is, that means the mass of water is simply, sir, 220 moist weight minus the dry weight, that is 180, and the weight will be 40 grams. Weight of the water will be 40 grams. So water content will be 40 grams upon mass of the solid is, that is 180 grams. Okay, because it is dry, there is only mass of the water, sorry, mass of the solid is multiply by 100. So 40 by 100, 40 by 100, absolutely correct, sir. 40 by 100. So it will be 400 by 18, 400 by 18, 400 by 18. So it is percentage. It is in percentage now. Okay. So it is in percentage now. 400 by 18. It will be 0. I think it will be around 0.222. Okay. It will be 22.22%. 22.22%. Okay. If we are not putting the value in the percentage, okay, we are directly noting water content 0.222. Okay. 0.222. And the answer will be so answer will be okay. Next question. Next. Next question. Next question. Void ratio is the ratio of, okay, void ratio is the ratio of volume of void is to the volume of the soil solids. And the porosity of the soil mass is the ratio of volume of void is to the total volume of the given soil. What will be the expression related to these two? So what is the relation? What is the correct relation? What is the correct relation? Anyone? Harshita, Arnab, anyone? What is the correct relation? So the correct relation is, your E is n by 1 minus n. N by 1 minus n. Absolutely correct. Your void ratio is E is n by 1 minus n. Absolutely correct. Another relation is, your n is E by 1 plus E. E by 1 plus E. Absolutely correct. E by 1 plus E. So if we are looking for the options, your n value is E plus 1. Absolutely wrong. E value is n by 1 plus n. Absolutely wrong. N value is E by 1 plus E. Absolutely correct. Okay. Absolutely correct. C is the answer. Okay. Sonu is saying C is the answer. Absolutely correct. So C is the answer. Okay. Next question. Next question for Sonu Bhai. Next question for the Sonu Bhai. Okay. So next question for the Sonu Bhai. So we have the soil in the soil mechanics and foundation engineering. The ratio of the density of the soil to that of the water is termed as. What is this termed as? What is this termed as? What is this termed as? So if we are looking for the specific gravity definition, if we are looking for the specific gravity definition, that is denoted by G, so that is simply equal to mass of the fluid or mass of the substance upon mass of the water. Sorry, density of the fluid or density with respect to density of the water, or it is unit weight of the fluid or substance with respect to the unit weight of the water. Okay, with respect to the unit weight of the water. So the ratio of density of the soil solids to that of the water will be simply termed as the specific gravity. So this is the relative term ratio, so no unit. Sir, G has the no unit. Okay, G has the no unit. Absolutely correct. So the last question, last question, last question. Rest will be discussed in next class. Rest will be discussed in the next class. So the water content in the soil is water content in the soil is how we'll define the water content in the soil. So the water content in the soil is your water content small w is simply denoted as mass of the soil is absolutely correct. Sorry, mass of the water upon mass of the solid is multiplied by 100. Okay, or it is simply weight of the solid is weight of the solid is upon weight of the water upon weight of the solid is multiplied by 100. So I'll mark down here. The water content is the ratio of volume of the water to the volume of the soil. The ratio of volume of the water, the ratio of weight of the water to the volume of the soil. The ratio of weight of the soil to the weight of the solid is absolutely correct. D is the answer. Okay. D is the answer. So this was today's class. Okay. So this was today's class. Rest will be discussed in next class. Okay. Rest will be discussed in the next class. Okay. So everyone, rest will be discussed in next class. Thank you so much, everyone. Thank you so much for joining the class. Thank you. Okay. So we have the complete solution for you here on the Resultant platform. So you are requested to download the app. Okay. You are requested to download the app and check our content. Check our content. Okay. So this is all about today's class. Next, rest will be discussed in later classes. Okay. So thank you so much. Thank you, everyone. Thank you so much.